Good morning, students. So today we are going to discuss about the mathematical induction problem. That is, the question is using mathematical induction 1 plus 2 plus 3 and so on plus n is equal to n into n plus 1 divided by 2. So as per the mathematical induction method, we have a three steps. That step 1 is we have to prove that P of 1 is true. Then we assume that P of k is true. Then we have to prove that P of k plus 1 is true. So let's we start the step 1. So step 1 is to prove P of 1 is true. P of 1 is true. Then we'll take the P of 1. So LHS. So left hand side, that P of 1, that is basically P of 1 is first term. So first term of the left hand side is 1. Then RHS, we have to prove that P of 1. So P of 1, we have to prove that n into 1 into 1. Formula is n into n plus 1 divided by 2. Then we have to replace the value of 1. Then 1 into 1 plus 1 divided by 2. Then 1 into 2 divided by 2. Then it is 1. So here the value LHS, the first value is 1. Then the RHS value P of 1 is also is the 1. So that P of 1 is both will be same value. Then P of 1 is true. So first step is completed when the P of 1 is true. Then next we have to prove that step 2, we have to assume that P of k is true. Assume that P of k is true. So when P of k is true means what is that? 1 plus 2 plus 3 plus also 1 plus k is equal to k into k plus 1 divided by. So in this step, we never do the prove that. It is assuming we have to prove that we have to true because of the value of P of 1 is true. Then we have, as per the method, we have to assume that P of k is also true. Then step 3, we have to prove that P of k plus 1 is true. So let me assume that already 1 plus 2 plus up to k is true. Let's see that P of k, then the LHS is equal to 1 plus 2 plus 3 plus also 1 plus k plus 1. K plus 1. So we have to prove that P of k plus 1. So we'll take up to the value of up to k plus 1. So see that already we know that 1 plus 2 plus 3 plus also on up to k. What is that? 1 to up to k. We know that k into k plus 1 divided by 2. So k into k plus 1 divided by 2. The remaining term is k plus 1. Then say k into k plus 1 plus k 2 into k plus 1 mixed fraction as concurrent to the fraction. Say k into k plus 1 plus 2 into k plus 1. See, divided by 2. Then here k plus 1 both sides we have common term. Then we'll take the k plus 1. The remaining term is k plus 2 divided by 2. So k plus 1, k plus 1, k plus 2. Then we will rewrite it as k plus 1, k plus 2, we will rewrite it as k plus 1 divided by 2. Okay, so let's see that P of k plus 1, the real meaning of RHS, we have to write it as whenever we have k, we have to replace a k plus 1. That is the proof. So the RHS says k plus 1, k plus 1 plus 1 divided by, let's see, k plus 1, left hand side, k plus 1, k plus 1 plus 1 divided by. Here also, the left hand side is right hand side, k plus 1, k plus 1 plus 1 divided by. So that the LHS is equal to RHS